Okay, guys, before we start, make sure you have a calculator with you. This is just a practice video for simplifying radicals and converting them into decimals correctly on your calculator. So you might find this review, but you might also need some practice here. We are going to be going into using quadratic formula, etc. for this remaining of this unit. So one of the things you'll find whenever you work with quadratic formula is numbers that look like these. And I want to make sure that you simplify them correctly and know how to use your calculator. It's a real important skill. So this practice sheet has 15 questions, but I couldn't fit them all on one screen. So it says here, simplify, that's where the hole punch went through, simplify and reduce each if possible. See, the thing is, not everything is possible to reduce. But if it is not reducible, I want you to just write NR, not reducible. But whether or not a number is reducible, you can still convert it into a decimal. And I'm going to ask you to round your decimals to the nearest hundredth. So there's question 1, 2, 3, all the way up to 9 you can see clearly. And then here's 10, 11, 12. So let me start this over here. Pause it, take a picture of it. Here we go. Pause it, take a picture of it, so you have all of the first 12. But I could not fit them all on one page because I write big. So here are the next ones. So 13, 14, and 15. On number 15, the hole punch went right through the number there, so I highlighted it. That number is supposed to be a 40, so square root 40 in there. All right. Now, of course, there's always an answer key because I want to make sure you're checking your work. So here we go. Here's the answer key for all 15. Now, I just want to make sure you know this. Like problem number 1. If you simplify this problem, that's the answer you'll get, and that is the decimal you should get when you punch it in on your calculator. And like I said before, not everything is reducible. So like problem number 2, I can't reduce the problem, so I wrote NR, not reducible, but I can still take it and turn it into a decimal. So once again, that would be the decimal answer I'm looking for. And of course, everything's rounded to 2 decimal places because that would be the hundredths place. So here, pause it, take a picture of it so you can check your answers as you go through. I'll get rid of all my little scribbles here so it's not in your way. But let's start to play. So the first thing is simplifying radicals. If you're going to simplify radicals, you have to know your perfect square numbers. So I wrote this on the side here where it says perfect square numbers because 2 squared is 4, 3 squared is 9, 4 squared 16, etc., etc. And it keeps going on forever, of course. But you know what? When you guys play with these numbers you're going to see, most of the time it's going to fall into this list. We're not going to encounter like really strange, huge numbers. Like what's the square root of 1026? We're not going to run into that very often. So this set of numbers will do you. And what I mean by simplify is this. Just same thing you did in Algebra 1. Like if you get an answer that's like square root of 40. You say, wait a minute, the square root of 40, I could say that's the same thing as 4 times 10. Because 4 is a perfect square, I can take the square root of that. It comes outside. So this could be simplified. I write it as 2 square root 10, or 2 rad 10. The word radical means root. So I use the word radical a lot. So 2 rad 10 would be the simplified version. Now, let's just play with another one. We'll do something like, what is the square root of 18? And you go, oh, 18? Well, that's 3 times 6. But here I want to stop you for a second. When you're simplifying a square root, 3 times 6 is truly 18. I agree with you. But 3 or 6 are not numbers we get to use when we simplify. So what you have to do is you look through the list of numbers and you say, what is the largest perfect square number that goes into 18? And then you say, oh, I get it. I'm not supposed to use just any old numbers. I'm supposed to use perfect square numbers. So 9 times 2 would be 18. And then what's the square root of 9? It's 3. So this answer becomes 3 root 2, or 3 rad 2. Now, any of these numbers that we're playing with, sometimes they give us a big one, like, 75. And you go, wait, 75, well, that's, 5 times 15. But wait, 5 and 15 aren't in our list of possible numbers. So I'm looking at it and I'm thinking, here it is. That's the guy I'm going to go for. So if I was to simplify, I would say this is 25 times 3, and then I'd say the square root of 25 is 5. So this answer simplifies, and I get 5 root 3. Now, any of these numbers here, I can punch them in on my calculator and turn them into a decimal. And these aren't hard. I just, I could punch in what is 2 times the root of 10. And it gives me some decimal number. So I say, hey, that's 6.32 if I rounded it off to the hundredths place. What about this guy here? What about 3 rad 2? 3 rad 2. I punch it in on my calculator and I round it off and I say, okay, it's approximately 4.24. And then what about 5 rad 3? So on your calculator, if you punched in 5 square root 3, I'm hoping that you got the same answer that I did, which is 8.66. And once again, I'm rounding everything off to the hundredths place. So I'm going 2 decimal places. So the thing is, these type of numbers are radicals. Yes, they are, and they're simplifiable. But what I want you guys to focus on are the type of numbers we're going to see when we use the quadratic formula. Because a lot of the answers we're going to get are going to look something like, 2 plus or minus rad 10 over 5, that kind of thing. So I want to walk you through some problems that look like this, but to save us both some time, I know these are the type of answers we get from the quadratic formula. But instead of using plus minus for mine, I'm just going to either use the plus or the minus so that we only have to go through it one time with the calculator. So let's begin. I have broken these next examples down by category. So let's just start playing here. We're going to look at something like this. And these are, like I said, the type of answers that we're going to get from quadratic formula. But instead of pluses, plus minus, like this one, I just used a plus. And this one, I just used a minus. This one, I just used a plus. So we're only going to punch it into the calculator one time. So here we go. The first step in cleaning up a number that looks like any of these is to simplify the radical. So what I'm looking for is, and I'm going to kind of go down a little bit, and I'm going to say the number under the radical is 24. I branch it off. I'm going to make a number tree, and I say to myself, the largest perfect square that goes into 24 is 4. 4 times 6. 4 times 6 is 24, and the square root of 4 produces a 2. So this number can be rewritten as 6 plus 2 rad 6 over 10. Well, guess what? Now I look at it and see if it's reducible. Look at all 3 outside numbers, and it must be all 3 outside numbers in order to reduce. What number would go into 6, 2, and 10? Well, always look at the tiniest number. That's your key. 2 goes into itself. It does. Hang on, I'm going to use a different color. 2 goes into itself once. 2 goes into that 3 times. 2 goes into that 5 times. Then I have a reduced answer. The answer I'm looking for is 3 plus root 6 over 5. Take a look at it for a second. That is the correct answer. I want to point out something that people do wrong all the time. They start the problem and they go, oh, I can reduce right here. That is not true. You can't reduce unless all 3 pieces have a common factor. That's why I use the highlighter pen on this one. Now, this is my answer. So I go, okay, I'm done, except for I have to convert that into a decimal. Now, here's the problem with calculators, every single one of them. Every single calculator has the same flaw. It does not know how to divide 2 things by 1 thing. It only knows how to divide, one number by 1 number. So what I have to do on my calculator is I have to get the top to turn into a decimal first. So on my calculator, I punch it in, 3 plus the square root of 6, and then I hit equals. Then I divide by 5. And if I do that, I ended up with, wrong pen. I ended up with 1.089, blah, 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 blah. I'm going to round to the hundredths place, so this turns out to be 1.09. So remember, I have to get this answer first on my calculator, then I divide it by the bottom. 1 number divided by 1 number. And that is one completed example. Now, as we get going here, the rhythm's going to pick up a little. But I want to make sure, because we do this for the whole, until we finish Unit 2, we're going to be doing this same skill. So I want to take some time here to make sure we're doing it right. So let's look at the second problem here. And I'm going to say, hey, 18 is simplifiable. It is. I'm not going to jump the gun. I'm not going to reduce right here. No! No! I'm going to say this is the same as 9 times 2. So what comes out? I get a 3 to come out. So I get 12 minus 3 rad 2, because a 3 comes out, square root of 9, over 6. Then I take a second, I pause, and I go to myself, do all 3 outside numbers have a common factor? And in this case, oh yeah, they do. They have a common factor of 3. 3 goes into itself once, 3 goes into that 4 times, 3 goes into that twice. So now I have to regroup my information, and I say 4 minus 1 rad 2, I don't have to write the 1 since it's a 1, over 2. And then you might be tempted, ooh, I'm going to reduce this again. No, you can't. You only reduce if there's 3 values there that have a common factor. That's the rule. Don't break it. I'm not lying. So here we go. Let's turn it into a decimal. On my calculator, I would say 4 minus the square root of 2, but I'm not going to say divided by 2. I'm just going to hit enter, or equals. And I get a big old decimal, 2 point blah, 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 blah stuff. But then I'm going to take that answer, then I divide it by 2. And on my calculator, I got 1.292, blah, blah, blah. But if I'm only rounding to this decimal place, the answer I want is 1.29. And that would be the decimal version of that. Let's play. Let's keep going. And I hope you see what makes all of these first examples exactly similar. All of them have something I can simplify right at the beginning. Okay, 75. take a look at our numbers here. What perfect square number goes into 75? 25. I think I did that as an earlier example, but that's 25 times 3. So I can pull out the number 5 because the square root of 25. Then I can rewrite this and I can say it's 10 plus 5 rads of 3 all over 20. And only now do I get to look and say, do all three of these numbers have a common factor? And yes, they do. That common factor is 5. So I could say 5 goes into that once, 5 goes into that twice, 5 goes into that 4 times. So if I clean this up and I rewrite this answer, I get 2 plus root 3, the whole thing divided by 4. And once again, don't do this. No. You only get to reduce if there's 3 numbers, so I already did that. I'm not going to double reduce it. And then let's see what the calculator says. 2 plus the square root of 3, hit equals, get that answer. But don't do anything yet because you have to still divide that answer by 4. And then I go divided by 4, and on my calculator I got 0.933, etc. But if I'm only rounding to here, I can say, hey, this rounds off to 0.93, and I'm done. So what we're practicing is just reducing these numbers and turning them into decimals with our calculator. And all of these examples, they simplified, and then I could reduce. Let's look at the next set of examples. And once again, what I did is I pasted the perfect squares down the page. Because when you're simplifying square roots, sometimes it's helpful to look at that list of numbers. If I were taking an open note test, I'd have that list of numbers handy. It would be very helpful. So let's look at this first one, because you're going to find that the only difference is now I put a number out in front to begin with. I put a number out in front to begin with. But I still look at the same exact spot. I look right here first and I say, can I simplify? The first rule is, can I simplify? And you know what? 10 is 5 times 2. But guess what? 5 and 2 are not in my list. So this thing is not simplifiable. Just because it's not simplifiable doesn't mean it's not reducible. Let's look again at the outside numbers. Those are the outside numbers. Do they all have a common factor? Always look at the tiniest number. And the tiniest number there is a 2. So I go, yeah, 2 goes into itself once. 2 goes into that twice. 2 goes into that 6 times. So I could reorganize this and say 6 plus 2 root 10. And if it's over 1, if it's divided by 1, I don't even have to write that, because anything divided by 1, you get what you got. So I'm going to get rid of that. Ding, ding. But I can still punch this into my calculator. I could say 6 plus 2 square roots of 10, and I get an answer. When I punch this thing in on the calculator, I got 12.324. So I'm going to just round it off and call it 12.32. I don't have to worry about dividing it by anything, because there's nothing on the bottom but a 1. Let's play. Does this simplify? Yes, it does. 4 times 3. I always have to choose numbers that are from this list to simplify. But I've got one. Now I'm going to pull out a 2. Now wait a minute, there's a number out front already. When a number comes outside and there's already a number there, what do? You multiply. So here we go. I get 4 minus, but now I'm having a 2 smack into a 3, I get a 6. Rad, what's left over? This guy. And what's on the bottom? That's a 10. So the first step is always simplify if you can. If it doesn't simplify, look for the next step, which is reduce. So I'm on the next step here. Can I reduce? Do all of these guys have something in common? And the answer is yes. Look at the smallest number, though. It's 4. 4 doesn't go into 6 or 10, so you got to go even smaller. 2 goes into that twice. 2 goes into that 3 times. 2 goes into that 5 times. The final answer is 2 minus 3 root 3 over 5. Now I'm going to punch that into my calculator. 2 minus 3 root, you didn't see that because it's on my calculator. So 2 minus 3 root 3 equals some ugly negative number, but then I'm going to divide it by 5, and this time my answer turned out to be negative 0.639 blah, 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 but all I care about is this guy right here is going to make this guy right here round up 1. So my final answer, if I was checking my work on the worksheet, would be negative 0.64. That's the answer for decimal form. Let's keep playing. Does this simplify? And I'm hoping you found the number of from the perfect square list and you went, oh, that's 9 times 5. So what's going to come outside? The 3 comes out, the 5 stays home. When these two guys meet, they're going to multiply. So what's my answer look like? It looks like negative 3 plus 3 times 5 is 15, rad 5 over 18. Can I reduce? Do all 3 numbers have a common factor? The answer is yeah. 3 goes into that 1 time. 3 goes into that 5 times. 3 goes into that 6 times. So we end up with a reduced final answer that looks like this. Now, I know that you've seen the quadratic formula. Everybody has by this point. But the thing is, you get answers from the quadratic formula that look like this, and if you forgot how to reduce them correctly, you'll think you're getting everything wrong when you might not be. But this is how to reduce. So I'm saying negative 1 plus 5 rad 5. I'm going to enter that on my calculator. I get some ugly number, 10.180, blah, blah, stuff like that. But I'm not done until I divide by 6. So remember, on your calculator, very important on the calc, you have to type that in and hit equals. Then you divide it by the bottom number, and if you do that correctly, on this one, I get 1.696. So be careful. When I round this up, because I'm going to round it up, it's going to tick over into the next column. So my answer would be 1.7. Even though I'm rounding to 2 decimal places, I get 1.7. Or you could say 1.70 if it makes you happy. All right? Cool. At any time, if you want to pause it and take a picture so you have some examples to refer to on your phone or something, that's great, or screenshot me or whatever. But I just want to kind of cover all the different things that could happen to you. Okay, what makes all of these examples similar? Can I do anything with rad 5? Can I do anything about rad 5? No. It doesn't simplify. It does not mean I can't reduce. It just means I cannot simplify. How about rad 6? Can I pull anything out of rad 6? Well, it's 2 times 3. Yeah, but 2 and 3 are not my numbers to play with. Oh, well then I can't simplify. And then this one, hey, I can't do anything about rad 2. I cannot simplify. But all of these particular examples do reduce. Let's play. Even though you can't simplify it, doesn't mean I can't go 2 goes into itself once, 2 goes into that twice, 2 goes into that 3 times. I could rewrite this as 3 plus 2 root 5. If it's a 1 on the bottom, I don't have to write it, and I'm not gonna. I'm done. But I can say 3 plus 2 root 5 on my calculator, and I can get this decimal answer that says 7.472. So I'm just going to round it off and call it 7.47. Next one. What do they all have in common? 2. 2 goes into this 5 times, 2 goes into this once, 2 goes into this twice. Let's regroup. I get negative 5 minus, now if it makes you happy and you want to write a 1 there, you can, but you don't need to. If all you see is one of them, then it means you only have one of them. So I personally do not write the 1 in. Can I convert it to a decimal now? Sure. I would do negative 5 minus the square root of 6. I would hit enter or equals. But I'm not done yet because I have to take that answer and divide it by 2. And I would end up with this funky decimal, negative 3.724, blah, blah. So I'm going to stop right there. That is rounded to the nearest hundredth. Okay, you know what? You try this one. I would say pause the video, see if you can just knock this one out, and then restart me. Go ahead, pause it and try it. I'm assuming you paused it and tried it. So let's see. I can't simplify, but I can reduce. All of these have a 3 in common, so I'd go 3 goes into it 1, thrice, 4 times. So my simplified version would look like this. 1 minus 3 rad 2 over 4. Now let's turn that thing into a decimal, but I'm going to do the top part first, 1 minus 3 rad 2. And I can just type it right in, and I get an answer. My answer I got was negative 3.242640687. But I'm not done. I have to take that answer and divide it by 4. And if I divide that answer by 4, then my calculator is going to tell me it's negative 0.8106, whatever, so I'm going to just round it off, call it negative 0.81. I hope you got that right. And remember, anytime you don't get something right and you need help, just come in and ask me questions in the room. All right. We have not looked at any of these yet. These are all non-reducible. When you run into a problem, look, I can't simplify this. I can't do anything about it. And look, all 3 numbers, 1, 2, 3, if they don't have a common factor besides 1, you can't reduce it. So on the assignment, I think you're going to run into this like on 3 of the problems. You can't do any reducing. Just write this, N, R. That just means to me you knew you could not reduce it. But it doesn't mean you can't turn it into a decimal. So I'm going to punch in on my calculator 1 plus 2 root 3. I'm going to hit equals. Then I'm going to say divide that answer by 5. And what does my calculator tell me? It tells me that I can turn this into a decimal, and it turns out to be 0.8928, blah, blah. But if all I'm doing is rounding to the hundredths place, I am done. Hey, this one has no reducible. Well, what if I put a 1 here? It still won't reduce because 1 is the smallest number. 1 goes into everything, but 1 doesn't help us reduce. Do I have to write the 1? No, you could get rid of it. This is not reducible. But it doesn't mean we can't turn it into a decimal. So 2 minus the square root of 10 equals negative 1.162277766, but I'm not done. I got to divide that by 3. And then I get negative 0.387. Whoa, 387. Let's round that off. Let's call that thing negative 0.39. I hope you're getting the hang of this because this last one is where everybody messes up. They do this right away. Oh, 2 goes into 4. Yeah. You just lost. Remember, it's 3 numbers. The trinity, the triple. the trifecta. The number outside rad 6 is a 1. I just wrote it in so you can see. You don't get to reduce this. This is still not reducible. But I can turn it into a decimal. So I'm going to say 4 plus the square root of 6 equals some number, 6.4494, blah, blah, blah. But I got to divide that by 2. And then my answer is 3.22. And that's what it rounds off to, and I am done. So just a reminder, guys, not everything will reduce. But it doesn't mean you can't turn it into a decimal. Now, last set of problems, I promise. This is it. Because these are the ones that have all the tricks I've talked about. So let's look. This is something I can write as 4 times 5. That'll let me take out a 2. And once I take out the 2, I will have 1 plus, what do I do with these guys? I multiply. Then this stays home, and this is on the bottom. And then I look, hey, 1, 2, 3 values on the outside. There's a triple. But guess what? This won't reduce. I was able to simplify it, but I can't do anything else. That's my answer. Let me get rid of the orange. I'm going to turn that into a decimal. So I'm going to say 1 plus 6 root 5. I hit equals. I get an answer, but then I got to divide it by 4. And that will give me a final answer of 3.60. I don't have to write the 0 because that's it. Let's take a look at this guy. 40 is a big number. But you know what? The only thing that goes into 40 from my list of perfect squares is 4. 4 is a workhorse. It does a lot of stuff. I'm going to take out a 2. And then I'm going to say, hey, that's 2 on the outside minus 2 times 8. That's going to give me 16 roots of 10 over 2. And I hope you simplified before you tried to reduce. Because I only get to reduce if 1, 2, 3 numbers. That's when I get to reduce. 2 goes into this once, 2 goes into this 8 times, 2 gets 1. So we have 1 minus 8 rad 10 over 1, but I don't have to write the 1 in the bottom. Let's make this a decimal. 1 minus 8 roots of 10 gives me negative 24.298. Oh, wait, 298. That means round it, but that kicks it over, and that, so negative 24.3 is what the answer is going to look like on that one. Now, I wanted to pick one big-looking number, but you know what? Whoop, I don't want you to see that yet. 98's a big number, but if you dink around with it, play around with it on your calculator, you're going to find one of these numbers over here goes into it. In fact, it's this guy right here, 49. 98 is 49 times 2. What comes out? 7. Oh, so I get negative 7 plus 7 rad 2 over 14. Now is the only time, now and only now, are all 3 numbers something go in? Yeah, 7 goes into all those. This becomes a 1, that becomes a 1, that becomes a 2. So I can simplify it and call it negative 1 plus 1 rad 2. I'm just going to say rad 2. But the whole thing is divided by 2. So I have to punch that in on the calc. Negative 1 plus the square root of 2. What's it equal? Some number. But I'm not done because I divide that by 2. And I get a rounded off answer of 0.21. That's what I get for that answer in decimal form. Okay. I hope that helped you. If you've ever struggled with that skill, that is something that I want to make sure we know. Because we're going to run into quadratic formula answers over and over again. We might as well simplify them correctly. So here we go. Here's what I've been saying all along. Always do the following to make sure your answers are correct. First, simplify the radical. Simplify the radical first. And that's if it's possible. Sometimes it's not possible, but if it's possible, you always simplify before you try to reduce anything. And then, once you do that, look for all three outside values to reduce. If it is not all three, it does not reduce, and leave it alone. That is the story. And when you are using your calculator, when converting to a decimal, get one number on top with your calculator before you divide by the bottom number. The thing is, here I'm going to show you, and this is totally true. You can check this on your calculator. All calculators only know how to divide one number by one number. It's true. They all do this. So if I wanted to look at this statement here. You have a thinking brain, so you can look at that and go, oh, 2 plus 6 is on the top. That means 8. And the bottom is an 8. So 8 divided by 8, 1's the answer. That is true. That's the answer I want. But if you just punch it in on your calculator, 2 plus 6 divided by 8, and you're not even thinking, 2 plus 6 divided by 8, your calculator is not going to see that you wanted to add these two together first. It's not. So your calculator is going to think you mean this, and it's going to tell you that's the answer. Well, guess what? Nothing hurts more than when you're doing a math question and you think you're right and you're totally not, because guess what? Your calculator totally does not know how to divide two numbers by one number. It doesn't. All calculators are brainless when it comes to that. So you got to know that. So I hope you found this video helpful if you've ever struggled with this concept, because it's going to be super valuable to you in the next unit, or this unit and the next unit. Okay.